What is mass? Mass is a common quantity to talk about in physics. It is linked to different types of energy, and it is commonly the subject of confusion for many students, as shown by the fact that they do not understand the difference between mass and weight. The SI unit for mass is the kilogram, and it is a good example of how education will often simplify ideas which become more complex in later years. Okay, the definition of mass is first met as: the mass of an object is the amount of stuff present. This is a terrible definition, and we can see why as we dissect this sentence. Amount. This term usually refers to a number where we want to know how much of the object is present, and this usually requires a value, presumably so that we can either use that number in a calculation or compare this value to the value for a different object. Stuff. This is the problem. What does stuff mean? Although the word stuff is vague, it does allow us to understand that the mass of an object is the same regardless of exactly where the object is. Typically, a question might ask how the mass of an object might change if it is moved from the Earth to the Moon. By thinking about the above definition, we can see that the object will not change, and so whatever we mean by the word stuff, there is the same amount of stuff in both locations, so the mass has not changed, i.e., the mass of an object on the Moon and on the Earth would be the same. Okay, the next stage is to change the word stuff for a better word. The mass of an object is the amount of matter present, but this is still vague. What is matter? And the answer: the matter in an object is the mass in the object. Okay, this is cyclic and not helpful. Mass is the amount of matter in an object, and the amount of matter means the amount of mass. So mass is matter is mass. This is pointless. So let's go to the next stage, which would be the definition above GCSE. When we say that kinetic energy is the energy associated with the motion of an object, and the motion is a reference to speed, we do not mean that kinetic energy is the speed. We mean that the equation for the kinetic energy has speed in it, i.e., by knowing the speed of an object, we should be able to calculate the kinetic energy. It is the same with mass. So here we go, a better definition for mass. Mass is a form of potential energy, and the link is in the equation E equals mc squared. Here, c is the speed of light, and when it is squared, i.e. multiplied by itself, this is a very big number. So mass is a very concentrated form of potential energy. For students above GCSE, this is why we may consider, for example, the mass of a proton is different if it is in a different nucleus. The mass of an object increases if the object moves faster. Both of the above statements make no sense if we only consider the GCSE definition of mass. But above GCSE, when we realise that mass is a form of energy, it is no longer a problem, since energy values can change. And this is also easily explaining why mass is not a conserved quantity in the universe. Just like any other type of energy, values can change from one form to another. So there you go. Mass.